Hello, everybody.
Hi, everyone.
Thank you. Thank you for joining us. Uh, we are welcome to this webinar. So, precision journey of the customized orthopedic shoes. We're gonna wait maybe 1 or 2 minutes to let the people join the session. I I'm here with Sarah from Duna, and we're gonna start in 1 minute. So all the on this during this webinar we will show the this show, and this is going to be recorded as well. So we're gonna allow we're gonna have a time at the end as well for the questions. So we will try to answer all the questions at the end of this webinar. So we're thrilled to have you join us for this exciting and an informative session on the manufacturing process of customized orthopedic shoes using the 3D scanning and specialized software. So today we will explore the innovative technologies that are transforming the way orthopedic footwear is designed and produced, ensuring precision, comfort, and improved patient outcomes. So please note that this webinar will be recorded, and at the end of the webinar, we will have the dedicated question and answer round. So we encourage you to write down any questions you may have during the presentation, and we'll be happy to address them and provide uh, the answers. So thank you for joining us. My name is Marcio Knapek. I'm sales application engineer at Pu3D. I'm based in Canada, and I'm very excited to join it today by Sarah from Duna S.r.l. Please welcome Sarah, and if you can introduce yourself and Duna.
Hi, everyone, and thank you, Marcio, for introducing me. I'm a biomedical engineer, and as you anticipated, I'm the technology development manager at Duna. Duna was founded as an artisan company in 1974, thanks to Franco Rosiglioni, who's the current the president, and was established as a benchmark in the orthopedic children footwear. Over the years, Duna introduced the manufacture of custom and mass-produced orthopedic footwear for men and women as well. And for 15 years, Duna has developed and brought to the market a technological line to support the production of footwear and insoles. And after 50 years of activity, Duna is confirmed as a leader in the orthopedic footwear industry in Italy, Europe, and beyond Europe.
Thank you, Sarah. So Sarah brings us wealth of knowledge and experience in the field of the orthopedic footwear and 3D scanning technology. So she has been in front of innovation at Duna, driving the advancements and that have significantly impacted patient care in the industry as a whole. So thank you, Sarah, for joining us today. And on this, the next slide, we will talk about the how the custom-made orthopedic shoes workflow. And this today we will delve in this comprehensive involved in creating the custom-made orthopedic shoes. So this is a process combining cutting-edge 3D scanning technology with the software that has been developed by Duna to ensure that each pair of shoes is perfect tailored to the individual's needs. Sarah, can you please share more information about the workflow that you follow at Duna to customize the shoes?
Yes, so Duna process for custom-made shoes starts with the scan of the foot using the PL3 scanner, and the output generated by the scanner in STL format integrates with iCAD Fit, which is a software developed together with our partner Inescope that allows to recognize the foot volumetry and to identify the foot measures. So the key feature of iCAD Fit is the possibility to place inclined planes whose intersection with the foot generates its fundamental circumferences, which are instead measured by hand in the traditional process. This information is then imported into Footura, which is a web app developed by Duna, through which is possible to configure the orthopedic shoes both from a technical and an aesthetic point of view. And at last, Footura allows the technician to send the order to our facility, and Duna designs and manufactures the shoes. In this kind of process, 3D scanning allows for the capture of the foot volumetry, which is particularly useful when designing the last on which the shoe will be built. And having the 3D reconstruction of the foot is critical, especially in pathological fit, and ensures a successful outcome with a perfect fit and no errors during the production phase. On the other hand, PLOS is relevant for scan post-processing, ensuring proper mesh cleaning and scan orientation, with the sole of the foot lying in the XY plane. And this latter is especially important for the integration between the scan and iCAD Fit software. So the process leading to the customization of orthopedic shoes is crucial for the well-being of the patient, both in prevention and treatment for certain foot conditions such as hallux valgus, plantar fasciitis, diabetes-related problem, or shoes that can accommodate braces. So in this context, 3D scan and the digital process act on time saving, of course, and optimizing the product without having the need for adjustments or remake after the first delivery to the patient.
Thank you, Sarah.
So in this process, we are in direct contact with the orthopedic shop that takes in the patient and take their measurements. After that, the technician configure the shoes and send the order to Duna, and we design, manufacture, and deliver the shoes. So this process, therefore, involves a specialized and qualified figure to configure the shoe, depending on each country legislation. In Italy, we have the orthopedic technician, in Germany, the shoemaker, and the certified prosthetist orthotist in other countries. So orthopedic footwear must necessarily go through medical prescription at first, and then through taking in charge the patient by the technician. And we have prepared a video to explain the process. So the first step is the 3D scan using PL3. The ideal position for the patient is the one in which the angle between the sole of the foot and the leg is 90 degrees, and the operator should rotate around the patient foot so as to acquire its full volume. After the scanning, PLOS software gives the possibility to post-process the mesh, obtaining a well-oriented and cleaned scan. And the STL file is exported from PLOS and then imported into iCAD Fit, which is the second step of this process. The main feature of iCAD Fit stands in the positioning of inclined planes to have the 6 fundamental circumferences of the foot: ball, behind ball, instep, heel, ankle, and upper end. And all these planes can be oriented and placed at the discretion of the operator. Then the third stage is the configuration of the orthopedic shoe. At first, a reference model is chosen from the catalog and imported, as we can see. And this model can be aesthetically customized in all its parts, such as upper, lining, closure, sole, and welt. and you can choose to leave the default setup or change some features. Then you have to upload the patient measurements, and having the PIL3, when you upload the iCAD fit files, the measurements are automatically imported. At the end of the configuration, you can arrange all the technical details of the shoe, such as padding, stiffener, and so on. And at last, the order is sent to Duna, and the shoe passes through all the manufacturing stages until they are ready to be shipped and given to the patient.
Here we are in another process. The shoes customization is very important for the comfort and long-term health benefits for the patient. And there is a part of the shoes that's even more important than the shoe itself. It's the insoles. So Duna has also included the manufacturing of this essential part of the shoes in their manufacturing process. And Sarah will explain this process for us.
Yes, as Marcio correctly said, insoles are a fundamental part of the orthopedic shoes, and along with it, they help to compensate or correct postural, biomechanical, or pathological behavior of the foot. In the same way as footwear, the process of manufacturing insoles also begins with the acquisition of the foot volumetry using the PIL3 scanner to scan the foot and PILOS software for post-processing operation. Then the clean-oriented scan is imported into Insole Designer, which is Duna proprietary software that allows the CAD design of the insole following two design flows. The first one is a flow that starts from the scan of the foot, and it is totally customized to the patient, while the second flow starts from pre-designed templates. In both cases, modification and therapeutic correction can be applied. Here, once again, scanning of the foot is fundamental to achieve a product totally tailored to the patient. And after designing the insoles, the CAM path is generated, and we move on the milling phase, in which the FRH series machine works EVA blocks of different densities, sizes, and heights. And both single station and four station machines can be included in this process. In this context, Duna offers different alternatives in the custom-made orthopedic insole workflow. So the digital insole production process can be differentiated in two ways. The first one involves the patient being taken care by the orthopedic shop. The technician takes the measurement of the foot and sends Duna the scans of the patient and the technical specification of the desired insole. Then Duna design and produces them. While the second process is entirely in charge of the orthopedic shop, whose technician take care of scanning the patient foot, designing the insoles and milling them. And the following video illustrates the process. So the first step is the 3D scan using PIL3. And basically using the same modalities that we have seen before. In this case, you can choose to scan the whole foot and part of the leg, or the sole of the foot and the lower part of the foot. After the scanning, PILOS software is used for post-processing operation and allows to obtain a well-oriented and clean scan. Now the STL file is exported from PILOS and imported into Insole Designer, which represents the second phase of the process. Insole Designer is a plugin of Rhinoceros, and in this video we will see the workflow for a full tailored insole for the patient. In this process, the foot and the last are superimposed, and the medial and lateral profile curves of the insole are drawn. And in this case, rulers are used to adjust the height of the insole. Then the lower surface of the foot is used to reconstruct the upper surface of the insole. And Duna Insole Designer also offers a wide range of therapeutic corrections that can be applied to the insole, such as arch support, pronation and supination, circular offloads, and metatarsal bars. In this case, we see in the video the arch support and the pronation and supination. The last phase of production consists in milling and finishing. Our milling machine is able to perform both single milling and double milling, giving the possibility to mill insoles with heel spring or pronation and supination. Finally, the insole can be covered and finished and inserted into the footwear so that a perfect match between the foot, the insole, and the shoe will be achieved. This is the case of custom-made insoles inserted inside a custom-made shoe. And as you can see, the match is perfect. Okay, so if we combine both processes, we get this workflow as a result, where the starting point is always scanning the foot with P3 and improving the mesh with PLOS software. After that, as for single processes, iCAD Fit allows you to take the circumferences of the foot. Footura allows you to configure the shoe and send the order to Duna. And finally, Duna manufactures the shoe, designs the insole, and mills them. So the result is a combination of shoe and insole totally customized to the patient, and that create a perfect match between the foot, the insole, and the shoe.
Thank you, Sarah, for this description of the workflow. Uh, I have prepared have some questions. Um, what it was the is the average time that Duna needs to complete this workflow from 3D scanning until the final products, shoes or insoles, and the insoles is manufactured?
From 3D scanning until the final shoe, the average time is 3-4 weeks more or less. And instead, for the time to complete the workflow to manufacture the insole is 5 or 7 working days, depending on the finishing of the insoles.
And when you implemented that the 3D scanning, how is the lead time was reduced by with the implementation of that technology?
The lead time is drastically reduced when in the traditional process is involved, for example, the cast. for the orthopedic shoes manufacturing. In this case, the process involving the cast is time consuming for the orthopedic shop, of course, because making cast takes about an hour for each patient, and it also creates problem with the disposal of excess material and safety related issues such as dust and chemicals are used. So 3D scanning is able to overcome these kind of problems, and sending the scan instead shipping the casts, of course, is immediate. On the other hand, having the 3D scan instead of the cast gives the possibility to Duna to work in parallel in certain phases of production.
And
So the
what
time
was the
is much more
ah,
reduced.
ah, okay. And what was the biggest challenge in integrating this 3D scanning into the traditional manufacturing workflow?
The main objective using 3D scanner is to reduce the lead time and reduce the non-conformity. In fact, accuracy is the most important point for us so that the model can have a good fit at first production and doesn't have the necessity for adjustment or remake. So, and from the orthopedic shop point of view, it avoids the use of chemical products in the measurement process, and taking measurements it's much faster.
And what is the material that your customers choose the most?
The most commonly used materials are leathers and textiles. And what changes between pathologies, however, is the construction and design techniques of the footwear. For patients suffering from diabetic foot, for example, larger volumes, elastic uppers, paddings, and seams in contact with the foot are used, and all these avoids rubbing and possible ulcers for the patient. Another type of shoe that require a special design is the shoe for braces, because it requires increased volumes and the use of straps or wheels lacing and facilitated foot entry.
So if you have a scanner, if I have a scanner, can I scan my feet and send you the data as a private person? How it works?
As a private person, no, this is not possible. Typically, since these are medical devices, product requirements must be established by qualified personnel, as indicated by the current law. So, for example, here in Italy, the process is the one that follows. So, doctor's prescription taken over by the orthopedic shop and then manufacturing. So there is always the intermediate of the orthopedic shop between us as Duna and the patient.
And as an expert, Sarah, what are the trends that you foresee in the shoes and the insoles customization field for the coming years?
For what concern the shoe, the trend in the next few years strongly depends on the welfare policies of each individual country. In any case, there is a tendency to move towards the production of product customized to the patient. On the other hand, regarding insoles, the trend will be towards the world of 3D printing, studying technologies and materials that guarantee orthopedic products with a characteristic equal or better than those of traditional insoles.
Thank you. Now I think we can open the Q&A, and I will check if we have any questions so far. We have one here. Uh, what kind of training is needed for retailers or clinics to adopt this technology? Do you provide a complete training in every step of the process?
Yes, of course, each hardware and software component of both processes require training, and Duna will provide all the training needed. In particular, I'm the responsible for the training of all scanning machine and iCAD fit, and then my colleagues dealing with the CAD-CAM system, milling machine, and technical configuration of the shoes. So we can provide you all the training and assistance that you need.
I have a second question here. How does the 3D scanning improve the accuracy of custom shoe design compared to the traditional method?
In this case, we can speak in quantitative terms. So the percentage of non-conformities before using 3D scanner was greater than 4%, while the current percentage of non-conformity using 3D scanning is less than 1%. So it is drastically reduced.
Next question. What level of customization is possible with this technology? Can it accommodate medical conditions like plantar fasciitis or flat feet?
Yes, of course, plantar fasciitis and flat foot are two of the most common and easy to treat conditions in reality. We also produce shoes for diabetic feet, which require special care, or shoes for amputated feet, in which we go to reconstruct the missing part of the foot, or shoes that can accommodate tutors, braces, and finally shoes that themselves become an orthotic. So the possibilities are endless and every level of customization is possible. And our motto as Duna is endless possibilities. So we can reach every level of customization.
And are there limitations in terms of shoe styles or materials when using the 3D scanning in milling? Or
No. One of our big advantage is to create functional orthopedic shoe that are at the same time aesthetically pleasing. So our modeling department strives daily to find aesthetic solution that make the shoe both useful and pretty to look at. So the only limitation in terms of style or material is introduced by the pathology of the foot, of course, and the consequent design necessities.
I have here the last question, and what
Mhm.
file formats are typically used for storing and transferring the 3D foot scan data?
Okay, the typical format is the STL format, which is an open format that allows to open the file from any 3D model viewer. So
Great.
it becomes an open system.
Don't have we don't have any other questions. So far we can maybe. So thank you everybody for being part of this webinar. Thank you, Sarah, for all these
Thank you.
detailed explanations about the manufacturing of the shoes and the insoles. And thank you everybody for joining us today.
Thank you.